Hi, this is another version of the next greater element question. You are given a zero indexed array of non-negative integer nums. For each integers in nums, you must find its respective second greater integer. The second greater integer of nums of I is nums of j such that j is greater than I, nums of j greater than nums of I. There exists exactly one index k such that nums of k greater than nums of I and I is less than k less than j. If there is no such nums of j, the second greater integer is considered to be -1. Example, the array 1, 2, 4, 3, the second greater integer of 1 is 4, and for 2 is 3, and that 3 and 4 is -1. Return an integer array answer where answer of I is the second greater integer of nums of I. We have the constraints here, the length of the array 10 to the power 5 and the value of the array enters less than 10 to the power 9. Okay, let's take this as an example and see how can we solve this problem. So we have the element 2, then 4, then 0, then 9, then 6, and the classical or the basic next greater problem, we use monotonic stack. Find the next greater element. What is the next greater element for 2? Is the element in the right side of 2 that is greater than 2, which is 4. For 4, 0 is less than 4, 9 is greater than 4, so it's 9. For 0, it's 9. For 9, there is no greater element in the right side of 9 which is greater than 9. So the answer will be -1. For 6 it's -1, and to calculate this or to find this answer, again we use the monotonic stack, and the time complexity of this is big of n. Now in our problem we need to find the second greater element. So for 2 we need to find two integers greater than 2. Here we have 4 and 9 greater than 2. The second one is 9, so the answer will be 9. For 4, we have 9 and 6 greater than 4, so the answer will be the second one, which is 6. For 0, 9 and 6, the answer will be 6. For 9, we don't have two integers greater than 9, so the answer will be -1. For 6, the answer also will be -1. How can we find this result? First of all, we need to using the monotonic stack, we will produce this output and store it in a dictionary. This dictionary will contains in its key, for example, we have 2. The result of 2 is 4, and in the key we will store the index of 4. So 4 index is 0, 1, so the key is 1, and what values has the results equal to 4. The value is 2. So we have a set of pairs. So we have 2. The index of 2 here is 0. Then we have 4. The answer is 9. What is the index of 9? 0, 1, 2, 3. So in the key we have 3, and we have a set of pairs. What are the pairs that its answer is 9? We have 4. 4 index is 1. Then for 0, again the answer is 9. 9 index is 3, so we will push also 0 to this set. 0 index is 2, so 0 comma 2, and remember this is set, so in the set it will be ordered, so this item become first and this pair become second. For 9 the answer is -1, we will not store anything. For 6 the answer is -1. So in the first loop of the monotonic stack we will generate this dictionary. Now in the second loop again we will use monotonic stack, but we will take an advantage of the dictionary we have created to generate the second greater element. So initially the stack will have the value 6. Now while we are sitting at different color, while we are sitting at 6, we look at this item here, and we see we check which values has this result, and this item is at index 3, so we need to loop over the sets of these values. The first value is 0 2, and we have 0 is less than 6, or 6 is greater than 0, so this is candidate, or this is an answer for the 0 value. So here we store 6. Then we have 4 at index 1. 6 is greater than 4, so this is an answer, which is the second greater element for 4. Then the loop is, the set is done. Then we need to check 9 and 6. 9 is greater than 6. As usual for the monotonic stack, it should be in order. We pop this from the stack, and the stacks now contain 9. Then we are at 9. We look at this element here, and we need to see if there is any values its result at index 2. We don't have any key here equal to 2, so we keep going. So the value here is 0. 0 is less than 9, so in the monotonic stack we have 0 9. Then at 0 we look at this item. Is there any value its result 4, which is at index 1? The answer is yes, we have this one, so we loop over all the items. Item here we have 2, so for 2 we have the answer. So we have this value 0, but 0 is less than 2, so we pop this item, and the stacks remain. The stacks only item is 9. So now 2 is less than 9. It means that this is an answer for the value 2. So we go for 2 and store 9, and the final answer for us will be 9 6 6, and here it's -1 and -1. Let's see the implementation. As we said here in the first stage, we have the dictionary that contains that maps the key integer with a set of pairs, and we use the monotonic stack to store the values in this dictionary. And here we clear the stack again to use it for the next loop. And in the next loop, as we said, we keep checking if the stack has value. We need to check for every iterator in the set, and as we loop over the set of this item, we will update our final result here, which in the next creator. So again, this is to clear stack used again. This will store final result, and here we use the monotonic stack algorithm again, and for every item we will take this iterator, which is the next from the dictionary we calculated here, and we keep looping as long as the stack has value. Now if the iterator itself is empty, so if there is no keys here, we will break this the stack. Otherwise we will check if nums of s.top is greater than or it's less than the element in here in this set. In that case, we need to pop from the stack because it's not a candidate. Otherwise, if the stack top is greater than the element in the set, so this is the answer that we need to store in the next greater, and we keep looping over all the set. Then we will move to the next element.